Okay, so got a question here from our homework assignment. This topic is distinguishing mixtures. There were two students who may be stuck on this, and so I want to do one with you. So here's the format of it. We've got two samples, sample A and sample B, and the question is, based upon the information they give us, is it a pure substance or is it a mixture? Or maybe we don't have enough information, right? So let's go through it and see. Really, the idea the idea is, can we take a sample, cut it in half, okay, and then consider these two halves separately, where we've got this half over here and this half over here, and they have different properties. How do you spell different? Let's try and make two F's here. Different properties, right? That's what the question is. Do we have evidence that they've got different properties? All right, so if we can, let's just go look at some examples. All right, so first of all, sample A. Got a solid yellow cube, 50 grams. Looks like we're going to divide it into two pieces, 25 and 25. The volume of the first, if they're both the same mass, but they have different sizes. Oh, okay, well, they must have different densities. Well, if that's true, this is definitely a mixture. Okay, let's go look at the second one. We'll do a few iterations of this. 100 grams, 15 grams is dissolved in ethanol. Half a milligram of the resulting black solution is carefully dropped onto a sheet of paper. After 30 minutes, there's a black stain. The initial round black stain is spread out and faded into a deep purple. Oh, also there's a green ring surrounding the inner stain. So we've got a green and a purple. Two different things. That's got to be a mixture. Right? Two different colors. Let's try another one. We'll try a couple of them and then we'll take questions from the floor if you have additional questions. So again, sample A, sample B. We're going to divide them out and see if we can find some difference, okay? It's a yellow cube, 50 grams. See that? It's a yellow cube, 50 grams. It's put into a pressure chamber and raised by increasing the pressure. At a pressure of 55 atmospheres, an orange liquid comes out of the cube. After 30 minutes, the flowing stops, and the smaller, lighter color cube sits. Okay, so it looks like we get to a point where we can no longer get any of the orange stuff out. We've got a cube still there and orange stuff on the outside. It looks like we separated it out, so that's a mixture. Right, the stuff that comes out at high pressure and then the stuff that doesn't. Okay, 100 grams of a coarse gray powder, faint and unpleasant smell. 15 milligrams of the powder into a tube and heated. The powder begins melting at 62. The temperature stays constant as the powder slowly melts. After the last of the powder melts, the temperature starts rising again and goes up to 76. Okay, so it looks like all of it all of it melts at 62 degrees. If we have a tight melting point, then that means it's a pure substance. Every once in a while I get one of these wrong. A tight melting point or tight boiling point means a pure substance. If it melts or boils over a range of temperatures, that's different. Oh, here's another one. 100 mils of a clear liquid. The density turns out to be such and such. The liquid then's cooled. We get down to 10 degrees. Crystals begin to form. After 30 minutes, no, okay, but it looks like some is still a liquid. We have some crystals and some a liquid. So in other words, they're different. So it must be a mixture. 100 grams, 15 milligrams of powder. It begins melting at 62. Temperature stays constant. This is one we had a minute ago. Temperature stays constant until it's all melted. After the last of it melts, that's a tight melting point. That's a pure substance. Okay, so there's a couple other iterations that you may be interested in. Feel free to send questions to me. Hopefully this is helpful.